Analyze and sketch the graph of x squared minus y squared plus 6x plus 34 is equal to 0. So the first thing you want to do, you want to complete the square so that you find the equation of a hyperbola in this case, because there's a minus coefficient of the y squared. You want to find this hyperbola equation in standard form, right? So you want to do x squared plus 6x, right? Write your x's first. And then complete the square, right? So to complete the square, you need to take 1/2 of this coefficient, which is 3, and then square that. You're going to get 9. And also subtract 9, because this positive 9 was not there before. Plus 9 minus 9 is the same thing as 0. And then minus y squared is equal to negative 34. And how do I get negative 34? I got it because I subtracted 34 on both sides. Right, so here we're going to get x plus 3, right? So this perfect square trinomial can be expressed as a perfect square. So perfect square trinomial in this case can be expressed as a binomial being squared. Binomial means two terms, and the way to define that is to write x first, and then write this being divided by 2. Plus 6 being divided by 2 is plus 3. Right, so you're adding 1/2 of this coefficient, x plus 3, and then squaring it, right, because you need to get the perfect square trinomial. Right, so as a result, this is equal to minus y squared, and I want to add the 9 on both sides. So if you add 9 on both sides, you're going to get minus 25. All right, so minus 25 on the right side. Now, dividing both sides by negative 25, and you should do that because in the standard form equation of hyperbola, the right side is equal to 1, right? So minus 25 minus 25. So as a result, what comes first is the y squared over and let's write it as 5 squared because we're going to need that. And then minus sign, right? Because there's a single minus, whereas in the y case there were two minuses. That's why the y becomes positive coefficient for the y squared. So y squared over 5 squared minus x plus 3 squared over, right? We already put the minus there. So again, 5 squared is equal to 1. Okay, good. So now we can analyze this equation. Remember that in this case, the standard form equation can be written as y minus k squared, okay, over a squared minus x minus h squared over b squared is equal to 1. So if we compare the numbers with the constants that we need to find, we understand that a value is equal to 5, b value is equal to 5 as well, right? This a and b both equal to 5. And then h and k determine the center, right? So hk in this case is what? So there's no minus k here, so obviously k is equal to 0, but what about the h? So minus h is equal to positive 3, so that means h is equal to negative 3, right? So minus 3 comma 0 is what the center is. Let's plot that. Minus 3 comma 0, right? So this is the center. This is the center. And as you know, the center is not a point through which the hyperbola actually passes through, right? So the hyperbola is on both sides. The vertices will be equidistant from this center. Is it going to be vertical line or horizontal line, right? So to do that, we have to plug in minus 3 into this equation that we've derived. Well, in this equation, that's a simpler one. If you plug in minus 3 here, so let me say x is equal to minus 3. What happens? This thing turns into a 0. Minus 3 plus 3 is 0. 0 squared is still 0. 0 divided by non-zero there is still 0. So that means you're subtracting nothing, right? So as a result, y squared over 5, well, over 25, let's put it that way, is equal to 1, right? Because this whole thing is 0, the second term. So as a result, what happens is you get two y values, right? Multiplying both sides by 25 means y squared is equal to 25. Square rooting both sides gives you plus minus square root of 25, which gives you y is equal to plus minus 5, right? So let's see. So minus 3 plus minus 5. So let's plot in those vertices, just vertices. 1, 2, 3, 4, 5. That's that. and also minus 5. 1, 2, 3, 4, 5. So what did that tell you? That tells you that the focal axis of this hyperbola will be parallel to the y-axis and not on the x-axis, right? So we already ruled out the fact that it's not going to be on the x-axis, right? The focal axis of this hyperbola will be parallel to the y-axis, right? So that's good. So we can already draw the hyperbola. It will look something like this. It will pass through this vertex, okay, and also the other way around through this vertex, right? So it will look something like this. And so now that we found the vertices, so let's see. So the vertices at minus 3, 5, and minus 3, minus 5, right? As we just found out, right? So the vertices, so we found the vertices, we found the center. Okay, let's circle that information. Now also we have to indicate that this is standard orientation, right? Because it's the focal axis is parallel to one of either axes, major axes. In this case, it's parallel to the y-axis, right? We can say standard orientation. Focal axis parallel to y-axis, right? As we've noted, right? Because as you can see, this is indeed parallel to the y-axis. Now the next part is going to be what? The next part is going to be to find the asymptotes. Well, first of all, let me see. So we have to find also the foci, right? The foci. So the foci have to hide behind the major vertices, right? So major vertices, so the foci will be surrounded by the hyperbola parts, in other words, right? So it will be a distance greater than the distance to the vertices from the center, right? So the foci will be more distance added and subtracted from the y value of the center point, right? So we have to find the foci. To find the foci, we're going to need to add the c and subtract c from the y value of the center. And we don't know the c yet, but we know a and b, right? A is equal to 5, b is equal to 5. So if we actually use the equation, and the equation, good news, is the same as the Pythagorean theorem that we know. A squared plus b squared is equal to c squared, okay? So we can solve for c squared directly by taking the square root. So c is equal to the square root of the sum of the squares of a and b, right? So that's going to be 25 plus 25. 25 plus 25. So that's equal to square root of, now remember that it's going to be a positive solution because c is only going to be positive, right? C is greater than 0. Okay, and also remember that c is greater than a and c is greater than b. So c is greater than 0 and it's also greater than a and it's greater than b. So that's why we don't have a minus, plus minus, we just have a plus, right? So that's going to be radical 50, which can be expressed as 25 times 2, so 5 radical 2, right? Square root of 25 is 5. 2 is still inside, that's why it's 5 radical 2. Okay, so that's the c value. So that means the foci at the x value is the same, right? Because we're talking about this focal axis here. So the x value is always going to be minus 3. And to the 0, like I said, to the y value of the center, you add the c value and subtract it, right? So it's going to be 5 radical 2 and also minus 5 radical 2, right? Because you subtract from 0, 0 minus 5 radical 2 is negative 5 radical 2, right? So these are your foci. And now finally, the last thing is to find the asymptotes, right? So the asymptotes will pass through the center point, and these asymptotes, 2 of them will make sure that they will be straight lines. They will make sure that the hyperbola never touches them. They're kind of like a barrier, right? Think of the 2 barriers that go through the center to make sure that the hyperbolas never hit them, right? They kind of enclose the hyperbolas in a way. They don't let them get too wild or too wide, right? For example, right? So let's actually plot the foci before. So 5 radical 2, 5 times radical 2 is going to be, let me see. So 5 times 2 is 10. 5 times radical 4 is 10, right? So that would be let me see, the calculator gives me 7.07, so just above 7 there. So I would plot it right there, and also 2 below, so that's there. So these are the Focis, Focis 2, Foci 1. And let's find the asymptote. So in this case, when we're talking about the focal axis parallel to the y-axis, we know that the asymptotes will be found by this equation. Y minus k is equal to plus minus a over b times x minus h. Now be careful. When the focal axis is parallel to the y-axis, you will have a over b. It's b over a when the focal axis is parallel to the x-axis or on the x-axis, whichever. But in this case, it's parallel to the y-axis, so it will be a over b, not b over a. Right? So plus minus a over b. So now what does that tell us? Let's substitute the number. So y minus, now what is the k value? The k value is 0. Plus minus a over b. A over b is, a is 5, b is 5. So we're talking about 5 over 5, which is 1. And then x minus, now what is the h? H is minus 3. Negating minus 3 gives you a plus 3, right? So that's it. So as a result, this equals to what? This equals to, let's see, what's the equation? Y is equal to plus minus x minus 3. X plus 3. All right? So that's it. So these are the asymptotes. Okay? So together, putting this all information down, this is what we have. Okay? So these are the key features of this hyperbola. Now, x plus minus x plus 3, if we plot it here, if we try to do the best job possible, x plus 3, so the y-intercept in both cases is positive 3, so it's going to pass through here. Okay, and it's going to have this, sorry, that was not 3, this is 3, right? So it's going to pass through this point. I know it looks like looks like the line is really far away from the, from the hyperbola in question, but that doesn't matter, right? Because the hyperbola will expand and it will get closer and closer to this, this side of this hyperbola will get closer and closer to this asymptotic line. And the same thing here, right? So plus minus 3. So as actually the y-intercept in the second case will be minus 3, right? Because we're talking about negating both x and 3. The negative applies to both, so it's going to be minus 3 for the second y-intercept. And it will pass through that same, it will pass through the same center point. So let's see, I think this makes sense. Okay, so this is what the asymptotic lines are, so we can label them as y is equal to x plus 3 with a positive slope, as you can see, the slope of 1, and this has a slope of negative 1. Y is equal to minus x minus 3. All right, so this is done correctly. So make sure you see. So you see, that's why I was saying there's a minus for the first and second term, so it's minus x minus 3 because you're negating both terms. That's why there are parentheses there. Okay, so these are the correct equations for the asymptotic lines. So I hope this was helpful and fun. Thanks for watching, and I'll see you in the next video.